Okay, like we have seen in the previous video, we have seen the beginning parts of the indices, and so we worked with a few examples there, though one of them was not complete, the last one. I apologize for that. So before we go on, subscribe, hit the subscribe button below there, and then you can either like or put a comment for what you want. I'll read it, then I'll rectify in the next video. So these are further examples with indices, and normally these indices that I'm going to work on are few things that come with A level. So I'll start with the first example there, which is simplify root of this half is a number, it's not a power, and we have the way it is there. So it's the first thing that we are going to work on. So like we said, under the laws of indices, this is the same as 1 minus x to the power a half. Remember, there is this a half here, and again we said that this, since it is negative, so we're going to get the reciprocal 1 plus x, and then the power becomes positive, plus here we have a half. Okay, then this has a negative power, so we shall get the reciprocal 1 minus x to power a half times 1 plus x. This root means a fraction of power, and everything is divided by 1 plus x. So we are going to work out this. So like you see here, these are all numerators, so when they multiply we only remain with 1 minus x to the power a half out of, so this and this will multiply into 1 plus x to the power a half. These two cannot enter here to get 2 plus 2x. 2 will only enter only if the power here is 1. But the moment the power is different from 1, then these two cannot enter. It will enter under few circumstances which I don't want to go in. So 2 will not enter. Plus, here we have 1 plus x to the power a half out of 2 into 1 minus x to the power a half. But remember, everything is divided by 1 plus x, this term here. So in our next step, I'm going to perform the LCM. Like we said, LCM is multiplying these two, which will give us 4, 1 plus x power a half, 1 minus x to power a half. Like I told you about a trick, we can multiply this and that as we get the independent terms, this and that, which we already have. So this term times this term gives you 2 into 1 minus x power a half, 1 minus x power a half, plus this term times this one shall have a 2 into 1 plus x power a half, 1 plus x power a half. But remember, we have this division here, but when it changes, you realize that what we are going to have is times 1 out of 1 plus x. This thing is the same as having power 1. Okay, so in our next step, we are going to see that these two terms here, this and that, have the same power. Sorry, have the same base, 1 minus x, 1 minus x. So we shall add the powers, which is going to give us here that 2 into 1 minus x to the power 1 plus, when we come back here, you look at this also having same base, 1 plus x, 1 plus x, so we shall add the powers. Then the 2 stays outside. So we shall write 2 into 1 plus x power 1. Everything. Now these ones down here will not add the powers simply because this is a plus and then this is a minus, so the bases are not the same. So it's only this one and this one that are sharing the base. No. This one and this one. So meaning that we can add the powers. So I'll have 1 half plus 1. Okay. Using your calculators there, you will get 3 over 2. So it's what I'm going to write here, and I say that this is 4. Okay. This is going to be 4 into 1 plus x to the power 3 out of 2, and again 1 minus x. This one has remained with the power a half. So we can simplify further when you look at the upper part, okay? And we shall have, since this power is 1, then 2 can enter, such that I have 2 minus 2x plus 2 plus 2x out of 4 into 1 plus x to the power 3 over 2, 1 minus x to the power 1 half. So you realize that this and this are additive inverses, so they give us a 0. So 2 plus 2 gives us a 4 out of 4 into 1 plus x to the power 3 over 2, 1 minus x to the power a half. Okay? So you realize that this and that will reduce and remain with 1 out of 1 plus x power 3 over 2, 1 minus x to the power a half. And that is the answer. So I'll go to the our second example. I'm going to work out this one, then give you a hint on this one. And this, the hint I'll give you will help you to solve. In case you don't, I always leave my WhatsApp number down there. You can always get back to me and I help you to continue with it. So we shall have x to power 2 out of 3 minus 5, this is part A, minus 5 x to power a third plus 6 equals 0. So now here, how are we going to apply the indices? So we are going to observe that on these first two terms of x, there is a common thing, which is third, okay? A third. And again, on the first one, there is a 2. So there is a way I'm going to write it, and I say that this is the same as x to power a third, but this is squared, okay? Because remember, this 2 out of 3 is the same as 2, times a third, okay? So this is correct. I can split it like that if you remember our laws of indices like we introduced. Minus, this one will stay the way it is, then plus 6, which is equal to 0. Then when you see that x power third is actually common, we can say let x to power a third be an unknown. We can choose, since my name is Luanyaga, I'll use L. So I'll have that L squared minus 5L. This L here is squared. The whole of this is L. It is squared. And then this is only x power third, so it is only L. Then plus 6 is equal to 0. So this is a quadratic equation. Okay? And when you reach this quadratic equation, there are so many formulas that we use, or methods that we shall use to solve a quadratic equation. One of them is the quadratic formula, which I derived in my first video. The other one is a factorization method, okay, that we can use. Now, I'm going to use the quadratic formula, which you normally call the bulldozer. So L is going to be equal to, okay, from the formula, I'll first write it from a side here, that x is equal to minus b plus or minus square root of b square minus 4ac out of 2a. So b is normally the coefficient of the term that has no power, a is the coefficient of the square term, and c is the constant term. So I'll substitute. You realize that b is actually negative, and where we are going to put it, there is a negative. So I'll write it as a positive 5 because of the minus and the minus. Plus or minus square root of b squared. Remember, b is minus 5, so it is squared. Minus 4, a is 1, c is 6. Then everything is divided by 2 times 1. So we're just going to write here our values of L, okay? So the two values of L that we are going to get from there are 2, and then 3. So these are not actually the values that I want, okay? It is me who introduced the L from here, but what I need to solve in the question is x, okay? So I'm going to use these two values of L to look for the unknown x. So I'll start. For L equals to 2, remember L is equal to x power a third, I'll have x to power a third equals 2. So now how do I deal with this to get this? So my aim will be making this power 1, so meaning that I'll cube both sides. Okay? So x, when I multiply a third time with 3, it will be giving 1, which is equal to, this is 8. So that is the first value of x. The second one, you say for L equals 3. So we say x to power a third is equal to 3. And you'll find out that your value of x is 27. So that's how we go about such numbers. So like I said in this second part, what I'll do is to give you a hint, then you'll use the hint to solve the number. If you fail, reach out to me via my WhatsApp. So when you look here, our aim is to see if we can possibly find a quadratic equation. Now when you look at this thing here, you realize that I can break it down and I write it in terms of x squared, this x power 4, okay? How? So this is going to be x power 4 equals x to power 2, again power 2. Meaning that I will have 4x squared, but again squared, minus a 15x squared minus a 4, which is equal to 0. Then again I will let, this time I'll let x squared be equal to maybe any letter of your choice. What do you prefer? M. So 4m is squared there, minus 15m minus 4, which is equal to 0. So you can continue from there. Thank you very much. Please subscribe down there. And in case of any comment, you can either comment on the video or in my WhatsApp, which is listed in the description. Thank you very much.